All right, hi class. Do you remember this triangle, Pascal triangle, and the binomial theorem? I want to finish these notes because you have one or two questions in the exam about the binomial theorem. So this is the Pascal triangle. You construct that. Okay, let's skip to the notes where we have left off. Okay, in here we talk about the pattern, right? When you have two terms, that's why it's called binomial. The powers of A is decreasing. The power of B is increasing, and then the number of coefficient is just the combination numbers. So, for example, if I ask you to expand, now we did the first two last time, all right? If I ask you to now expand 2a minus 5y to the power of 7, first, your n number is 7. Your first term is 2a, all right? Your first term is 2a. Your second term is negative 5a. Don't forget the negative. Then what happened? Okay, with 7, you have 8 terms. 1, 2, 3, 4, 5, 6, 7, 8. It's always one more than the n number. You have 8 terms. It starts with the coefficient. It's the row, the 7th row. So you look at your Pascal triangle. Look at the row that has the number 7 there. Here, it says 1, 7, 21, 35, 35, and back down because it's symmetrical. So that would be your coefficient. Your coefficient for your 8 term will be 1, 7, 21, 35, and then back down 35, 21, 7, and 1. That's the coefficient for your 8 term. Now, the first term, 2a, will have descending order. Start from 2a7, the power of 7, right? And then 2a power of 6, 2a power of 5, 2a power of 4, 2a power of 3, 2a power of 2, 2a power of 1, we don't need to write 1, 2a power of 0, we don't need to write at all. And then the second term, you go from 0, so we don't need to write that at all, to 1, to twice, to 3 times, 4, 5, 6, and finally 7. Now you just simplified it. So look here, 2 to the power of 7, 2, 4, 8, 16, 32, 61, 128. So there's 128a7. The second term, this is a minus sign there. And look at the number, 2 to the power of 6 is 64. 64 times 7 times 5, I'm using my calculator right now, is 2240. And then a61y. Next one will be plus 2 to the power of 5 times 21 times 5 to the power of 2. So which will give you, wow, this huge number. And then a5y2 and so on. So you see there's pattern there. There's a quick way to find out the binomial expansion. You don't really need to multiply 2a minus 5y 7 times to get the answer. Knowing this secret or this math trick, you can find the answer very quickly. And then you see the pattern. a7, a6, a5, right? No y, 1y, y squared, and so on. So in general, this is the binomial theorem, all right? And now you can see every term will have specific, like every term has the same form, okay? If you consider this is my first term, this is my second term, this is my third term, all right? You will see the number there, like 0, 0 for your first term, 1, 1 for your second term. So in your formula sheet, they have the following formula. I'm just copying down this same form. Like if this is term 3, look at what term is it. If you have a 2 here, this becomes 3. If you have a k here, this becomes term k plus 1. Like it's always one more. And look at here, you have an n number here, so this is the tn plus 1. So for any binomial expansion to the power of n, you have n plus 1 term, so it match. So therefore, this general form become my formula. Whenever I'm looking for a t term, the formula is nck a n minus k b to the power of k. This way you don't need to write out all the terms. You can just write this formula and you find the answer. Let me give you an example. So you can just use this form to answer the following question. The question is, determine the fourth term of the expansion of x minus 3 to the power of 9. Okay, so first the number n is the number of exponent you have. N is 9. All right, you're looking for the fourth term. You're looking for the fourth term, which is like this. This is like we study sequence and series back in grade 11. We write term, right? Fourth term. According to my formula, if you're looking for the fourth term, look at this formula. What number plus 1 is 4? It's 3, right? So when you look into the fourth term, it's same as letting k be 3. That's how you use it. Look into the fourth term, let k be 3. So this is how you match this formula. Now let's use my formula. NCK. NCK. Remember we say looking for the fourth term, you're looking for case 1 less than the term you're looking at. This is always the case. That's why the formula has a plus 1 there. And now a is your first term, which is my x here, to the power of 9 minus 3, n minus k. And into my b is, this is my a, this is my b. Negative 3 to the power of k. So this way you don't need to count, you don't need to write out the whole thing. You just use this formula, you can find a specific term. So for 9c3, just put it in a calculator. So I'm putting it in a calculator right now. 9c3 give me 84. X to the power of 6. Negative 3 to the power of 3 is negative 27. So you times 84 by 27. The final answer is negative 2268 x6. This is the fourth term of the expansion. Okay, good. Now there are other types of question make it more interesting, right? Not as straightforward. It won't just ask you what's the 10th term. For 10th term, just let k be 9. Very straightforward. In here, it says find the middle term. Oh, what does that mean? Well, look here. You have 12 terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? Remember we say the number of terms is always one more than n. So what is the middle term among here? If you have 13 terms, the one in the middle, right? The one in the middle is here. There will be 6 above it, 6 below it. After that, so there's one term in the middle. So together there's 13 terms. So it's here. Okay. So to find out the number of term is always your number divided by 2 plus 1. All right. So if you're n, so this term is the seventh term. So this question is just asking you what's the seventh term. To look for the seventh term, my k will be 6. 6 plus 1. Let's use my formula. NCK, my a, n minus 1, my b, and then k. Okay, so just put that in your calculator, you get the answer. Not very bad. Next, okay, write the constant term. This will be our last example to conclude binomial theorem. Constant term of this. What is a constant term? Constant term is the term that doesn't have any x value. Usually if you have just a binomial, normal binomial, your last term will be the constant term, right? But here it's different. Okay, when you look at this, your constant term is not in the end. Let's take a look. Now, let me just count by the, like if I do it, it will be 8c0 is my first term, x to the power of 8, right? And then the second one, ac1, x to the power of 7, and then now including that one, to the power of x once. My third term will be x to the power of 6, and then 2x to the power of 2, right? You can see here, when you get to the point where they both equal, they will cancel out. So if you just go 2 more times, 3, x5, 2x3, and then this term, ac4, x4, 2 over x to the power of 4. Okay, one is in decreasing order, right? The other one is increasing order this way, and then you have still other term. But then this one, all the x will cancel out. That's your constant term. So again, using your calculator, a to the power of 4 is 70. X4 And then 2 to the power of 4 is 16 over x4, they cancel out. So your constant term is 70 times 60, 1120. That's your answer. Okay, so I hope to show you some variety of binomial expansion questions. And then there's a form, this is in the formula sheet that you can use. All right, so wish you good luck tomorrow for the mock exam. You may not be ready because we don't have time to review everything. I give you a practice test so you can try that. And tomorrow, just come in, do the test, do the best as you can. And again, because you have 3 hours, only 40 questions. For each question, just take the answer, plug in the calculator. Just use, don't say cheat, just use skill. Using your calculator, check each answer, just use different way, graph them, like plug it in, just work backwards. So just don't guess in the diploma exam. You don't need to because you have so many time. Just take your time, try each one by one. If you're stuck in one question, move on to the next one and come back later. All right. So wish you good luck. Wish you learn something in the exam. Okay. So use it as a diagnostic test, as I suggested. Don't come in and feel, oh, I'm going to fail it. Come in and feel that I'm going to learn something from it. Do your best. Don't guess. Try your best. And then after the mock, we mark it and we look at it, and then we will spend time on the unit on the type of questions that you are weak at. The questions that you can do, we don't need to spend time redoing it. All right. So use it as a diagnostic tool. All right. Good luck. See you everyone. Bye.